Okay, I'm going to work through Chapter 2, problem number 35. This is a problem in one-dimensional motion. In this particular problem, we're told that a driver has a reaction time of 0.5 seconds, and the maximum deceleration of her car is given as maximum deceleration is 6.0 meters per second squared. And she is driving at 20 meters per second when she sees an obstacle 50 meters in front of her. Can she stop? So her initial velocity is 20 meters per second. She sees something, steps on the brake. So let's sketch this out. There's a car. It's traveling along at 20 meters per second. She sees an obstacle that's 50 meters in front of her. So this distance we'll call x is 50 meters. She's traveling at 20 meters per second. Her maximum deceleration is 6 meters per second squared. And the question is, can she stop before hitting the obstacle? So what we want to know is, how long does it take her to come to a stop, or how far does she travel while she's decelerating? So there's two parts to this. Notice that we're given the reaction time of the driver is 0.5 seconds. That means that she sees it when she's 50 meters away, but it takes a half a second before she reacts to that. So the first part is the reaction, and in that part there is no braking. She's just cruising along at 20 meters per second. So how far does she go? Let's go ahead and just set it up the full way with all of our kinematic parameters. We're interested to know how much closer she gets to that obstacle during the time that her brain is processing what she's just seen. She's traveling at 20 meters per second. She has not reacted, so she's not stepping on the brakes, so there's no acceleration, but we're given the reaction time is 0.5 seconds, so that's the duration of this particular thing. The final velocity is also 20 meters per second since there's no deceleration, but we don't really care about that. We don't need it. We're just looking for x. So the distance that we travel here is just VIT plus 1/2 AT squared, which in the case of zero acceleration, this second term is 0. So that just becomes VI times t, or 20 times 0.5. So the distance traveled before she even hits the brake is 20 times 0.5, or 10 meters. Okay, so now she has 40 meters, and the question is, can she stop before she hits that? So in the second part of the problem, she is decelerating, or braking, at 6 meters per second squared. Of course, she's decelerating. That means that acceleration is in the opposite direction of her motion. We'll go ahead and tabulate what we know here. And what we know is that her initial velocity is 20 meters per second, and we're interested in the time it takes for her to stop. So her final velocity is 0. Her acceleration, here I have to be very careful to put a minus before that acceleration, minus 6.0 meters per second squared. What I'm interested in is, how far does she travel during that deceleration? If it's less than 40 meters, which is how much space she has left before she hits this thing, she's okay. If it's more than 40 meters, there's an accident. I don't particularly care how long that takes, but just fill in the table there. So I'm looking for x. I have 1, 2, 3 other parameters. The kinematic equation that relates these four is 2ax equals Vf squared minus Vi squared. So that gives me 2 times minus 6 times x equals 0 minus 20 squared. And that gives me then x equals minus 400, that's 20 squared, divided by minus 12, and that is, I know I'm going to be okay because 40 over 12 is less than, 400 over 12 is less than 40. So let's see exactly what it is. 400 divided by 12 is 33 meters. So the total distance traveled is 10 while she's reacting plus 33 or 43 meters, and that's less than the 50 meters that she had before the obstacle.